Okay, so we're back. We're still in section 7 of chapter 1, so this is 1.07. The video was getting a little long, so I broke it up into 2 videos. And what we're talking about now are known as binary operations. Well, binary ought to kind of make you think of computer operations, and that's where you would see a lot of binary operations going on. It's because it's a way to simplify the language that when you're programming a computer. Let's take a look at an example. We were doing Harry Potter characters, so we'll stick with that. We'll go Hermione. So this is example Hermione. And what we're going to do is we're going to say that if I take a number, right now we'll just call it x, and I've invented this new operation, and I'll call it a heart. So x heart y, where x heart y is equal to and 4x plus y. So what I've defined is I've defined this new operation. It's not addition, it's not subtraction or whatever. It's defined as take the first number, multiply it by 4, and then add the second number. So let's take a look at an example. If I asked you to define what 4 heart 6 is, okay, you just follow this rule. It says take the first number and multiply it by 4, so 4 times 4, and then add the second number, which is 6. So 4 heart 6 is 16 plus 6 equals 22. That's a binary operation. If you were asking a computer to do the same operation again and again and again and again, it's easier to define an operation. See, this is just 2 things being hearted together, as opposed to this, which is you've got 2 unknowns, a number, and an operation. So this is actually simpler than this, and that process speeds up computer programming. Let's take a look at another one. Example, okay, I need a good character from Harry Potter. Let's do Snape. Okay, so example Snake. If a, I need a symbol. Oh, here's a good one. Hopefully you can tell that's a cat. So I've defined an operation. It's cat. A cat B equals is the same as saying 2 times 3a plus 2b. So I've defined the cat symbol as being this. All right? So what we want to do is, what is 7 cat 9? Okay, so A is defined as the 7 and B is defined as the 9. So we just take 7, put it in for A, take 9 and put it in for B. So this becomes 2 times 3 times 7 plus 2 times 9, which is 2 times the sum of 21 and 18, which is 2 times 39, which is 78. Okay. But now I've got a question. I'm not going to do it. I'm going to leave this to you to figure out. We know addition is commutative. 3 plus 5 is the same as 5 plus 3. We know multiplication is commutative. 7 times 3 is the same as 3 times 7. Is my new defined operation kitty cat, is that commutative? That is, if I do 7 kitty cat 9, would I get the same thing if I did 9 kitty cat 7? What does that equal? Is it the same? Am I going to get the same answer, 78, that I got? Or will I get 78 here, same as I got 78 here, if I reverse the numbers? Well, I'm not going to answer that one. I'm going to leave that one up to you to do a little exploring on your own. So that ends the second video of lesson 1.07.